Okay, on 1 through 9, you're going to want to make use of these angles that I found, which 30, 45, and 60 you already knew. To place it in the second quadrant, all I did was subtract from 180 to find each of those. This just saves us time later. To place it in the third quadrant, you add to 180, so 30 plus 180, 45 plus 180, 60 plus 180. To place it in the fourth, you subtract from 360. So 360 minus 30, minus 45, minus 60. See, that's how I arrived at those. But it's good just to have them already done so you can refer to this. If I want to find the sine of 15 degrees exactly, and the reason I'm going to say exactly is you guys can hit your calculator and find the sine of 15 degrees, right?
Yes.
There was, and it's been some time, it's probably been about 15 years ago, there was a bridge in New England, one of the New England states, which are the blizzards happening now, collapsed. And the reason it collapsed is one of the engineers didn't do exact trig.
Oh.
There's a difference between the decimal when you use on here, it's going to keep on going forever and ever and ever, right? But exact stays and you can keep it all the way through and you make less mistakes, less chance of error if you use exact trig. So I know you can find the sine of 15 on your calculator and we're going to compare it to our answer here in just a minute. But we're going to find it exactly. And you're going to find it exactly by using sum or differences. Either one will get us there. And there's more than one way to skin a cat, I've said that a lot, because there's more than one combination of these numbers I can add or subtract to get 15. Right off the bat I can see I can take 45 minus 30. That works, doesn't it? That gives me 15. 60 minus 45. 240 minus 225. There's a lot of combinations in that group. It does not matter what combination you use. Does everybody understand what I just said? Does not matter. So just to make it simple, I'm going to use the one I first thought of, 45 minus 30. Is everybody okay with that? So to get the sine of 15, it's the sine of 45 minus 30. Now, I rewrote your formulas for you, but they're on the front page of your trig information sheet. The sine of 45 minus 30, I'm going to make use of this formula, right?
Yes.
So it's the sine of the first one, cosine of the second one, minus sine of the second one, cosine of the first one. Okay, now, make sure you're on the side with the chart. So that's why you may want the formulas written somewhere else, because otherwise you're going to be flipping back and forth all the time. What is the sine of 45? Square root of 2 over 2. What's the square root? What's the cosine of 30? Okay. What's the sine of 30? What's the cosine of 45? So multiplying, I get the square root of 6 over 4. Multiplying the square root of 2 over 4. So they have the same denominators. And that would be my answer. And that's the exact answer for the sine of 15 degrees. Now, somebody with a calculator. Find the sine of 15 degrees. What did you get?
0.25881.
0.25. Just remember that. Okay, now let's see if this is the same. So everybody got a calculator to try it? Take the square root of 6, subtract the square root of 2, hit equal, and divide it by 4.
0.2588190.
So we got the same thing. Do you guys see what I'm saying? But when you're doing calculations and building a bridge or building a road, this is what you're going to want to use as opposed to that 0.26. Because this you aren't going to lose any decimals. It's going to stay within the problem all the way. Everybody see the difference there? Now, hopefully you got these, you know them. We're going to go on to the next one. How would I find the cosine of 15 degrees? What would be one way I can manipulate these to come up with the cosine of 15 degrees? Well, I could use 45 minus 30 again, couldn't I? But I want to do something different this time.
60 minus 45.
60 minus 45. So what is the formula for cosine of A minus B? Cosine of the first one, cosine of the second one. This is subtraction, so it's the opposite, so it's plus sine of the first one, sine of the second one. And now you turn to your chart. What's the cosine of 60 degrees? 1/2. What's the cosine of 45 degrees? What's the sine of 60 degrees?
Square root of 3 over 2.
And what's the sine of 45? Radical 2 over 2?
Yep.
So I get the square root of 2 over 4 plus the square root of 6 over 4. Which normally when you're working with sines and cosines, you're going to have a square root of 2 and a square root of 6 somewhere in the problem. Now, again, can't we check this? What's the cosine of 15 on your calculator approximately?
0.97.
0.97?
Yeah.
Okay, now, what's the square root of 2 plus the square root of 6? So you go square root of 2 plus the square root of 6, say it equal, and divide it by 4. So you can check every answer. Okay, now, what if I want the tangent of 15 degrees? We could use the formula for tangent, but what did I say yesterday that we could also do? In fact, we derived the formula. Could you take sine divided by cosine? Don't we know that's the case? So if I took the sine of 15 degrees divided by the cosine of 15 degrees, isn't that going to create tangent? Don't we already know the answer for the sine of 15 degrees?
Yeah.
Don't we know the answer for the cosine of 15 degrees?
Yeah.
So, and you're dividing, so can I go ahead and invert and multiply?
Yeah.
So it's the sine, invert the cosine, multiply, what happens? The 4's cancel, so I get the square root of 6 minus the square root of 2 over the square root of 2 plus the square root of 6, which you can't leave radicals in a denominator, we learned that a long time ago. But if they're involved in addition or subtraction, you multiply by the conjugate, right? The one where the sign in the middle is opposite. You've been doing this since Algebra 2, and you did it first of this year as well, when you did college algebra. So square root of 2 minus the square root of 6. All I did was change the sign in between. That's called a conjugate. Okay, when you multiply conjugate, there's something nice to know, that when you multiply conjugates, all you have to do is take first times first and last times last, because the inner and outer are always canceled. So all I need to do is take a radical 2 times a radical 2 is 2, and a radical 6 times a radical 6 is 6. Isn't it 6? Well, you could say the square root of 36, which is 6. On top, what do I have to do, though? FOIL. So what's first times first? Square root of 12. We'll worry about simplifying later. What's the outer? Negative 6, because the radical times the radical is itself. What about the inner? And last times last? Okay, now, combining like terms, radical 12 plus a radical 12 is 2 radical 12. 6 minus, a negative 6 minus 2 is a negative 8. What can 12 be simplified to? What perfect square goes into it? 4 times 3, right? So the square root of 4 is 2, so that's going to make that 4 square roots of 3 minus 8 over, what's 2 minus 6? So can't now I divide everything by negative 4? So that would make that a negative radical 3. Negative 8 divided by negative 4 is 2. And that's simplified to an answer. Now, let's check it, right? No reason to miss anything, you can check them. What's 2 plus, or 2 minus the square root of 3? Just put it in your calculator that way. 2 minus the square root of 3. Well, square root of 3 is about 1.7, so 2 minus it's going to be about 0.3 something. Yeah, so about 0.3, so 0.26. Now, what's the tangent of 15? So is it the same thing?
Yeah.
Yeah. Does everybody follow what we did?
Yeah.
Okay, let's do another one. Now, if you've got this one written down, you don't need to write another one.
This one that we're about to do or the next one?
This one that we're writing down now, you don't have to write down.
Okay.
If you got one down, you're good.
Alright.
All I want you to do is to comprehend. Let's think of another angle. Let's say I want, I want to find the sine of 75 degrees. Somebody tell me a way I can get 75.
30 degrees is 45. Adding
Okay, 30 plus 45.
30.
I agree. We've used 30 and 45 and 60, so I want something different this time.
300 minus 225.
There's one. Is everybody okay with that one?
Yeah.
So sine, and the reason I want to do this is to show what happens. What did you say, 225?
Yeah.
When we're in a different quadrant. Okay? If you're in a different quadrant, then you have to worry about all students take calculus, the SIGN, the signs of them. Okay, so if we're using 300 minus 225, that would be sine of the first one, cosine of the second one.
Plus.
On sine, it's the same.
Okay.
So minus sine of the second one, cosine of the first one. The reg concur. Now, what's the sine of 300? You're going to go underneath the 300 column and tell me what's in the sine of 300. So it should be square root of 3 over 2. But what quadrant was this from?
Fourth quadrant.
And in the fourth quadrant,
It's not
it's negative. Okay, so that's the only thing you got to worry about if you use anything second, third, fourth quadrant. You got to worry about their sign, the SIGN, whether it's positive or negative. Cosine of 225, what quadrant? Third. What do I already know in the third quadrant? Is the cosine positive or is it negative?
Negative.
It's negative, so I'm going to go ahead and put it on there. Now, what is the cosine of 225? Look underneath the column. What is it there? Square root of 2 over 2. Minus, that's third quadrant. What's the sign in the third quadrant? Negative. And what's in that radical 2 over 2 as well? You guys should have these memorized, but we can use that chart. Cosine of 300, that's fourth quadrant. So cosine is positive in the fourth quadrant, so I don't need to change it. What is the cosine of 300?
1/2.
1/2. Now let's do the calculation. So negative times a negative would be a radical 6 over 4. 2 negatives make a positive. So radical 6 plus the square root of 2 all over 4. Now, what's the sine of 75? Do the decimal, and then somebody else put it in the calculator and see if we agree.
0.96.
Okay, so you should be able to check all of your answers to see whether or not you come up with that. Okay, what if I want, let's do another one, I'm just making another one up. Let's say I want the cosine of 165. How can I get 165? What was that?
135%.
I still didn't hear you, Richard.
135 plus 30.
135 plus 30? Does everybody agree with that one?
Yeah.
Okay. 135 plus 30. So what's the formula? Cosine of the first one. Cosine of the second one.
Minus
Minus.
Sine of the first one.
sine of the first times sine of the second.
That looks like I don't know what there. Okay, so 135 is in the second quadrant. What is the cosine in the second quadrant?
Negative.
Negative. Okay, now what is the cosine of 135? Look underneath your table.
Or square root.
What's the cosine of 30? You can get that one straight off.
Square root of 3 over 2.
What's the sine in the second quadrant?
Positive.
So I don't need to worry about that one. And isn't it radical 2 over 2?
Mhm.
And what's the sine of 30?
1/2.
So we get negative square root of 6 over 4 minus square root of 2 over 4. So negative square root of 6 minus the square root of 2 all over 4. And again, can you double check it? If you do cosine of 165, it should be the same thing as the negative square root of 6 minus the square root of 2 all divided by 4. So that's what you're doing on 1 through 9. You're gonna manipulate these until you come up with the right combination in addition or subtraction to find the sine, the cosine, and the tangent. And then you can find tangent. You don't have to use the tangent formula. All you gotta do is take your two answers and divide them. Then in addition to that, you're gonna practice also what we did yesterday. What if I tell you that the sine of A is a -3/5 and A is in the third quadrant? Yesterday they're all in the first. I'm going to put them in different quadrants. Cosine of B is a -5/13 and it's going to be in the second quadrant. Find the sine of A plus B. Now, one thing nice about the group of problems I have you do, you're only going to have to set up your triangle once. Both triangles once, because then you're going to answer 6 questions about it. Because you can reuse it. Does everybody understand what I'm saying there? Yesterday in the assignment, you had to draw 2 triangles for each problem, right?
Yeah.
Now it's just 1 for 6. So what's this triangle going to be? Sine is opposite over hypotenuse, so what's this part?
4.
And we're in the third quadrant. I always put it in the triangle so that way I can go back and remember what I need. This is angle A.
And the negative is matter?
I don't put the negatives in it. It only matters down here when you put it into your formula. Okay, cosine is adjacent over hypotenuse. So Pythagorean's theorem. So B is going to be 12. And we're second quadrant. Now, I asked you to find the sine of A plus B. What's the formula for sine of A plus B? Sine of the first
Cosine of the second, plus sine of the second, cosine of the first.
So now I just go to my triangles and get the correct answer. So what's sine of A? We know what that is because we already have it up here. Cosine of B we already have, -5/13. But what's the sine of B? Remember we're in the second quadrant. What's the sine in the second quadrant?
Positive.
Positive, and the sine would be 12/13. What's the cosine of A? It's in the third quadrant, so what's the cosine? Negative, and cosine is adjacent over hypotenuse, so it'd be -4/5. Now you just do your math. And what's a -3 times a -5? And 5 times 13 is 65. I know we can simplify that, but it's not going to help us because we have to have a common denominator to add anyway. Over here we're going to get what? -48/65? So we get a -33/65 for our answer? Everybody concur? So that we practiced yesterday.
Yeah.
And that's what you guys missed out on. We did setting up the triangles based upon a specific trig, and then you put that information into the formulas. Okay, do you guys want another example? We can do more.
No.
Wait, can you do one more like that?
One more, now on the assignment, you're gonna be using the same pair of triangles. But then it'll say, find the cosine of A minus B. Okay?
Just go through the functions.
Yes, you just write the formula down and then you plug them back in.
Let's do this.
Yes, Mason?
Since they're in the second quadrant, where did the signs change at when we were doing our work?
Right here. That one we already knew what it is, that one we already knew what it is. Right here, the cosine of A. A is what? Cosine is what in the third quadrant? It's negative, so I put the negative in it.
Okay.
So you gotta pay attention when you get it from the triangle, what quadrant it's coming
Okay.
from. Okay, are we good there?
No.
Okay. Go ahead and shut it off, and then I think I'll work with Becky and Karen to make sure you know how to set up the triangle. Okay, in fact, why don't you get your book?